Now we are going to flip back to talk about you as the educators specifically. And this presentation is called Custom Games for the Classroom. First, we're going to talk about thinking about CS plus X, which is computer science plus another subject. That games aren't just about coding. I know we at Arcade love to teach coding through games, but they're about so much more than that. And hopefully, what you pull out of this session is that you can code for fun, not just to learn how to teach your students, not just because your principal said you had to, but actually for fun because you enjoy it. And I'll give some project examples, some resources for you, and then we'll do the survey. This is me. I'm going to assume not all of you have been on since the very beginning, so I will reintroduce myself. My name is Kiki Prottsman. I am at Kiki VSIT on all social media, at least all social media I can think of. And I started off with my own nonprofit. I worked at code.org for years. I started off their curriculum and then moved to the K-5 version and created CS Fundamentals. I came to Make Code in 2020, and I love it here. And just a side note, I haven't said yet in any of my intros, I'm here because I love Make Code. I didn't love Make Code because I'm here. And I think that that is something that's important to mention. Our producer for this session is Ben Villalobos. Ben is an engineer on the VS Code EDU team, Villalobos. And you can learn more about VS Code EDU at vscodeedu.com. Thank you, Ben, for being here to produce me today.
Happy to be here.
So you'll hear me yelling at him every once in a while, especially if things start to go wrong on my end. All right, let's talk about CS plus X. So this is something you're going to be seeing more and more. In the CS education world, we made a huge push to try to get computer science to be its own course. We really did want kids to learn authentic computer science and to some extent learn it quite rigorously. And that has taken off in many areas, specifically in high school, but it's a little less practical for younger students. And it's really important to get younger students interested in computer science. And I'll go into that more later, but this is to say that one of the ways we can authentically bring computer science down to very, very young students is to integrate it into other subjects. That's what the X is about. So computer science is a tool. And when people see computer science as something that they can use, it becomes more effective than seeing computer science as a subject that you have to be a member of. I'm going to talk to you about two ideas that I call the escalator method. And there's two pieces to the escalator method. The first one is that we need to make sure that we're not expecting students to come meet us at computer science. We're not expecting them to come meet us in AP classes, to come meet us at college level computer science classes. That's too much to hope for. I call that the teleportation method. Like they might get there, but there could also be some very valuable pieces missing. So with the escalator method, we come down to meet them where we are. And so I would think of Annie, who is a graphic designer. She's an artist and she wants to be an artist. Everything about her says artist. Or her friend Lisa, who's an actress. She wants to be in theater. She wants to eventually be in movies. And to try to get them to switch their personality and now see themselves as a computer scientist is a very hefty ask. It's something that makes them not feel like themselves anymore, unless they've gone through that progression themselves. So instead of making them change who they see themselves as so that they feel comfortable sitting in that college level computer science course, we need to bring computer science to them in their acting class, bring computer science to them in their art course, show them that it's a skill and a technique that will serve them their entire lives. And now it's no longer you need to change yourself to be in computer science. It's computer science is already meant for you. You already belong together. So, uh, it's just a whole mind shift. And now they're more likely to take that entry level computer science course because they took some computer science in art class and they realized that it could really help them out. And that the more they learn, the more powerful their skills will be in the area that they want to study. So that's one of the subjects. The other piece to the escalator method is how we teach that computer science. So a lot of educators want students to jump in and be rigorous right away. When I created Thinkersmith and we brought computer science down to elementary school and we were using block based programming and we were talking about the vocabulary as if it were something more playful, using beads, using uh, stackable cups in their classrooms, people accused it of being watered down. They said that it wasn't real computer science, it was watered down and that it wouldn't do any good. But I think that as an educator, we understand everything needs to be developmentally appropriate. And when you start with something like an unplugged lesson where you're literally stacking cups, shout out my robotic friends, hey, to learn how to code and to learn about algorithms, then everybody's on a level playing field. Um, it's not just the people who self-selected into computer science that are now experiencing these ideas. It's anybody who can stack a cup. So that's the same idea where you're starting down where they are and helping them come up every step of the way. And teachers might think that it is time expensive, that it takes more time to do this. And in a way, they're right. In the beginning, it will take more time. But since each student will come with you throughout the journey, they will understand more because they'll be interested and they won't be telling themselves they can't do this. So by the time they get to the top of the escalator, the students who've had the gentle ride up will be more confident and actually understand more than the students who were kind of forced and pulled up to the top. They might get their assignments done, they might be getting good grades, but it doesn't mean they'll be comfortable and truly believe in themselves. So STEM from Dance is a cool initiative that literally blends dance and CS. Yes, I love the idea of STEM and dance, not just like the algorithm of the routines and everything, but even you've seen people do lighting in their costumes and all sorts of technology happens on stage. If you've been to a big concert, you can see people with amazing stuff going on behind them and even the way that the lifts work, it's all just super duper powerful. Okay, games aren't just about coding. So, games authentically speak to people. Everybody plays games. There is not a demographic that is not represented in the gaming industry. And I don't know if you know this, and I don't remember if I put a slide in here. I think I did. But gaming is a very equal number of women to men, a very equal number of those who are adults to those who are kids. Gaming is for everybody. So, just in the chat there, please don't tell us what it is. Do not describe it. You don't want to look it up. Trust me. But how many of you know what shigellosis is? But how many of you have heard of dysentery? I'm going to guess that that number goes way up. How many of you have heard of dysentery? Let's get some of those in the chat. And those of you who have heard of dysentery are probably somewhere around my age. Um, and this is thanks to Oregon Trail. So we learned about a whole lot of diseases in Oregon Trail, and they stuck with us, right? These are things we remember, even though shigellosis and dysentery are exactly the same thing. Uh, so many more people know of dysentery because of the connection to games and things felt so real. You feel so connected that even now, years later, I remember dysentery. Thankfully, I've never had it. Okay, so here's the statistic. Okay, it was 46%. So it's not just about coding, universal reach, shared experience, cross cultural. so much uh, research about games and how games help students learn. When people are having fun, they retain information better than when they're zoning out and they're trying not to fall asleep and they're feeling left out. It's also about intrinsic motivation, like the desire to actually learn it, not learn it because grades are telling you to, not learn it because the next class you need is going to need it, but because you're interested in it, because it's going to help you make a better game, or it's going to help you um, feel like you accomplished something if you get to the next level. It creates this lasting knowledge that sticks with you, and it's very playful, and most of the time, these types of games have positive experiences for their players. Games are built in such a way that they'll be a positive experience. So, with that, I wanna talk more about you coding for your classroom, not just bringing coding to the classroom, but the understanding that you as an educator can create games for your students' classes. And if you teach computer science, that's fine. You can make games about coding. But think about making games for the math teacher. Think about making games for the English teacher. I've heard so many teachers complain about how the big game houses don't really understand what they need in their classroom. Well, you do. So if you want to play around with arcade, if you want to learn how to make games that your students could then take to learn more about math, to learn more about spelling, to learn more about history, it's completely possible. And it doesn't take that much, and it's absolutely free. So we're going to dig into that a little bit. All right, I have two examples here, but I do want to ask the chat, what would you make if you could code a game for fun for your classroom? What kind of game do you wish you could have in your classroom? I'm still seeing talk about dysentery in the chat. I'll see if I can change that subject a little. What kind of game would you want to see in your classroom? Oh, simple snakes game. Yeah, that's easy enough to code. All right, we've got FPS. So I've put these two games together. Let's see, where did my links go? Oh no. There we go. All right, I'm going to click on it. There we go, and hope that the link comes up. It looks like my slides shifted, so my links are at the bottom. But I'm going to choose one of these. I think I'm going to choose this Dino Math one here, and I'm going to click on it, and I'll show you what I did. So real quick, I'm going to open a new tab, and I'm going to go to arcade.makecode.com. And this was built using the Save the Dinos skill map. So what I did was I took a basic game that we already have the building blocks for, and you can do this with any of our skill maps, with any of our games. Oh, I see someone who said story driven. I love that. We do also have a story driven skill map right here. So if you want something for history, if you want something for English, full of stories is great. Also, if you are a little adventurous, and by that I mean willing to learn more about things like functions and conditionals, some more hefty concepts, then Code and Adventure is a great story game. It has that kind of choose your own adventure feel. So you write your story and then you can split them depending on if they say this, they go this way, and if you say that, they go that way. That's great to use for both the history, English, any kind of story-driven game. So for this math game, I would just go through. I'm not going to have time, unfortunately, to build the whole thing in front of you, but I can kind of show you what I did in order to make it. So I followed the skill map, and this skill map walked me through everything from putting the background in to making the background move, adding the mama dinosaur. And this is one of our entry level skill maps. So, oh, baby dinosaur, we're not ready for you yet. This is one of our entry level skill maps. So you'll see that it has the actual block that you need, and it's even pre-filled. So that's something that makes this go by a little more quickly, a little more easily. You'll see I already have my mama dino on the screen there. Let's go ahead and shrink that down. And so I would just go through and build each step of the way and then continue through and continue on to the next one. And I'm not sure if I actually put the animation in for this one, but I'll click over to it and we can check. So I'm going to click on that tab and I'm going to open my Dino math game. So you can see, I've got to make a decision. You can see that I'm using a very similar mechanic. I've got even the same road. Uh-oh, I'm going to kill myself if I don't actually think about what I'm doing here. So in this case, I have the Dino set to a number, and down in the corner there, you'll see that we're multiplying by nines. So I have nines and I want 9 times what is 45. So 9 times what is 36. And then every time I get one, it shifts and I have to find something else. So 9 times 9 is 81. And you can make them go slower if you feel like this is too fast for your students. You're in control. So you get to make all the choices here. You get to choose if it's dinosaurs and bats, if it's dinosaurs and baby dinosaurs, if it's nines. That it's hard to play while you're talking, as it turns out. If if it's nines, if it's eights, if it changes, you get to make all of those decisions, which is why it's so cool and so powerful when you can design these on your own. So I'm going to open up my code here and it's going to look a little bit crazy when you come in from nowhere, like when you haven't seen any of the building and you haven't been there step by step. It's going to look like there's quite a lot going on here. And I guess that's fair. But when you've been the one building it step by step, each decision makes sense to you. And if you're building something for math, you probably already know your the type of math you're trying to teach. And if you don't, you would not believe how clarifying coding is. Uh, you have to get things crystal clear in your brain. And there have been so many times I've been making a game for something and I go, "Oh, that's why it's like that." Okay. So, yeah, that's what I did. I took the base skill map to make my base game. And then I said, I need to add the ability to say what number we're doing the multiplications for. So then I went in and said, well, how do I do that? How do I say I want this to be the number that we're doing this for? And let me find my on start here. Here we go. And so I made a variable. And now I have that piece. That piece is good. And then I had to start thinking about other things like how do I say that I want the dinosaur to say, this is a product that I want you to look for the other piece to. So it's going to have to be 9 times something equals this thing that's going to be above the dinosaur's head. And I built a lot of stuff in place and then I tidied it up later by making functions. And you can see I made a function called call new product because I wanted to do it more than just in the OnStart. I found I needed to do it again after I got the correct answer. I needed to find a new product to put in that speech bubble. So I ended up making an entire function for it. This function didn't come to my head like I know the stream team does stuff constantly and they probably have functions pre-built in their heads all the time. But that's not how it works for me all the time. Sometimes I have sort of an idea how I might do something, and then it turns out that that won't work at all in practice. So I go through and I just start adding block by block. How do I put a speech bubble above the dinosaur's head? How do I make sure that whatever I am multiplying is going to be within the range of what the students already know how to do? And so that last one I solved by using a pick random between 0 and 10. So I know that my students can multiply 9 by anything from 0 to 10, and that's what we're practicing. I'm just going to put that range in there. I'm going to put a say block in, and so have the mama dinosaur say. Comment, how to know which code is specified for which function. Oh, we got this earlier. So here's how we connect functions in make code. First, it's very important, and this is something that we don't enforce in arcade, but that as an educator you can promote and you can enforce, is that it's pretty important to make sure your function is named what you want the function to do, right? It should be descriptive. So because this function is coming up with a new product to show over Mama Dino's head, I called it new product. That way, when I'm looking through my list of functions, functions live down here under this advanced tab. So okay, as it turns out, I only had one function in this game. Bad example, but you could have 20. And when you're looking through your functions, you know that new product makes a new product. This is why it's so important not to just name your function X or foo or bar. I know there's some of you out there who do that because they're not very descriptive. So if you start getting a whole pile of functions, you're going to forget which ones these do. So for modularity's sake, making sure that everything is nice, tidy, clean, and all by itself, just give it a nice descriptive name. And then everything in this container belongs to this function. So I can see how I can move this function around. That also means I could copy it out of here, paste it into another game if I was working with other people. Um, yeah, so everything in here, the purpose of it is to serve adding that new product to the top of the dinosaur's head. And then to link to that, to actually call it, we have these call blocks that we can put in where we actually want that code to go. So this, that is equivalent to this. And the reason that I didn't just leave it the way it was and I put it in a function is because I have to use it more than one place. If I was just using it there, honestly, I might have still put it in a function and given it a name because it's just so much code that it's a good way to clarify what that chunk of code does. But because I'm using it somewhere else, I didn't want to have all that code in two places. So this just keeps everything cleaner. That was a great question. Yeah. So then each step of the way, when I figured out, oh, I want this to be able to happen, I just said, okay, where in the code do I want that to be? If I want this idea of a multiplier to be on the bat's head, how many of you have ever gone to a webinar and done this in front of everybody live? Yeah. So if I want that multiplier to show up on top of the bat's head, I need to figure out where the bats are coming from. And so I went into my code. I found out where the bats are coming from. And then I needed to be able to choose a multiplier, but not just any multiplier, right? I needed to make sure that the correct option was in there somewhere, or it would be a pretty bad game. So I just used random numbers. I used a list of numbers and I took the product over the dinosaur's head divided by whatever number we're using, which was 9. And I made sure that was in the array. And then I made sure that there was 1 on either side of it. And then I kind of have an outlier that uses a random number that could be 2, up to 2 on either side of it. And that gives some options for the kids to have to choose from. And then as I was putting it over the bat's head, I just pulled each item out of the array so it didn't exist in the array anymore. So there weren't duplicates unless one of the numbers was already a duplicate. So it is not to say that your games have to come out as if an expert built them. What I'm trying to say is you can go through easily any of the arcade tutorials step by step. You can find a tutorial that you can then start thinking, how could I make this for my class? Make this something educational for my class. You'll see in this one right here, in this target practice one, um, this is about syllables. So the ball says how many syllables of a word that your students are looking for. And then the words come across on the target. and you only get points for knocking over the target with one syllable word. And that changes every time. So it could be a two-syllable word next time and a three-syllable word the time after that. So it gets students thinking, and they don't have to know how to code. They're just playing your game like this. They're playing target words. Target words is a game that they play in spelling class. They look for the words that have the right amount of syllables, and that one doesn't. And they go through, and it's just something that they play. They might know you made it, they might not know you made it, but it becomes part of their cultural lexicon. Okay, that is my soapbox. I just want to encourage you to try coding yourself for you, for the good of your students, and not, it doesn't always have to be about bringing the coding to your students, although that's pretty cool too, right? So I wanted to leave you with these links, arcade.makecode.com, forum.makecode.com. That's where we can continue the conversation after ArcadeCon. Go over to forum, uh, visit the educator lounge, and chat with us. If there's any links that you didn't get because the comments are going by so fast, we'll have all that information over there in the forum. I also write a blog called Kiki's Corner, and you can read about all sorts of things on Kiki's Corner about how to do basically every little thing in arcade. Um, and we have educators page that has a bunch of resources for educators as well. And like I've been mentioning, please don't forget to go over to at MS Make Code. At MS Make Code is the educator YouTube channel. And if you subscribe over there, you'll be able to see all of the sessions from today. And then the at Microsoft Make Code is the student facing version. Oh, someone has heard of Kiki's Corner. Yay. Thank you very much for that. All right. Cheers, everyone.